Okay, here we're on our second last group of questions for this assignment. A tall tree in a park has broken off 20 feet above the ground, so that the top of the tree now touches the ground at an angle. So we had a tree, it's a beautiful tree, it snapped off somewhere, and now we have a tree that it's got its head on the ground, broken bits here, broken bits there. Here's the ground. So, beautiful artwork aside, let's just make it look like a triangle. So we've got a triangle. So, let's make it like that, I don't know. So, a tall tree in a park is broken off 20 feet above the ground. So it broke 20 feet off the ground, so that's 20 feet. Top of the tree, so that has to be the top of the tree now touches the ground at an angle. Angle of inclination from the top of the tree on the ground to the top of the stump. So the top of the tree used to be standing up, here's its top now. Okay, to the top of the stump, here's the broken off part of the tree, is 40 degrees. How high, oh man, was the tree before it broke? Okay, so if we fix this tree, we can't fix the tree, but if we fix this tree, if we take the tree that is like this and we bend it back up so that this part here is now standing right straight up again. Here's the top. We put it back up right. How high would it be? So that's going to be the length of both the 20 feet plus the hypotenuse side. So this plus this height of the tree. Okay, so we know 20 feet, we need to know hypotenuse, we do know the angle. This angle is 40, which means that this is our opposite. We know opposite and hypotenuse, that's sine. We are looking for the hypotenuse. We need to dig it out of there. And we do that, we get our hypotenuse is equal to our opposite side over sine of theta, which in this case is 20 feet, over the sine of 40 degrees. And 20 over the sine of 40 is 0.64, so 20 over that is 31.1 feet. So this one here is 31.1 feet. This was 20 feet. If I add them together, if I take 20 feet from the stump plus 31.1 feet that fell over, I get 51.1 feet. And that is not any of our choices. Interesting. So I'm going to double check this later in the next couple of minutes after we record the rest of this video, but I'm betting that there's something wrong in here. The other possibility is that I made a mistake, which we all know couldn't be. So here we have determined the ratio for angle T. Angle T is right here. And I'm looking for tangent. Tangent is opposite over adjacent. For angle T, this is my opposite side. And this is my adjacent side. Let's move this line there. So opposite side is 35. So I need 35 on the top, which means it's not any of these guys. And my adjacent side, well, I'm not sure what it is, but I know it can't be 37 because 37 is the hypotenuse, that's the longest side. So it better be 12, so it better be A, but let's check. We can always find the length of side ST, the adjacent side, by using Pythagorean theorem. We start with our generic form. We realize we're solving for one of the smaller sides. Take the root of both of these sides. If I take 37 and I square it, subtract 35 squared, I get 144. And root 144 is 12. So, yes, it was 12. Great. So this one here works out. 35 and the adjacent side is 12. This was all really not necessary because this was multiple choice, but it's good to check things out anyway. Yeah, I'm going to check this one out here, and if it's the case that the answer really should be 51.1, then I will update the question. And if it's the case that I made a mistake, then I'll delete this video and you'll never know about it. I guess you'll find out which one.